Hello, this is Chuck in the Planetarium reaching out to you again with another interesting lesson about seasons today. A topic that can definitely give students and even adults some challenges. So let's get right to it because there's a lot to digest here. And if you have any problems at all, just remember you can pause the video, you can go back and start the video again. You can see it as often as you need to get the concepts down. And it does take a little practice. But I want to start with this picture. So you got four yellow poles here. They're vertical poles. And I'm wondering if you don't notice anything peculiar about this picture, because there's something very interesting about it. Take a moment. If you have to pause the video, do so. But we're going to go right into what's so peculiar about it. And that is, these poles are not cast in a shadow. Not at all. They're perfectly vertical. The day this picture was taken, sunny, clear, beautiful day, not a cloud in the sky. Notice, though, that the cars are casting a shadow straight down. That means the sun is directly overhead in this picture. This picture was taken in Lahaina, Hawaii. This beautiful town. If you've ever been there or haven't been there, get to it. There's Hawaii down there in the Pacific Ocean. And believe it or not, that picture and that phenomenon is called Lahaina noon, and it occurs when the sun is directly overhead and you cast no shadow. When that's the case, you cast no shadow. It can happen in Lahaina. It can happen in Hawaii. It cannot happen in Virginia Beach. It can't happen anywhere up here. In no other state in the United States can there be a day when the sun is directly overhead. And that generally surprises a lot of people because I've met people, you ask them, they think the sun goes directly over their head every single day, all year long. And when I tell them, not only does it do that, it never goes directly over our head because of where we are on planet Earth. So here's the thing, for the sun to be directly over your head, you have to be somewhere on planet Earth between the Tropic of Capricorn in the Tropic of Cancer. Now, that's not to say that it's every single location in here has a Lahaina noon every day. That's not what happens. This happened in Lahaina. That picture with the yellow poles only occurred for about a minute or so, and then the poles started making shadows as the Earth was rotating. Okay? Well, maybe that's not correct, but they don't cast shadows more than one day. Over time, the sun will shine in different locations here and get back to there. So it happens twice a year. Okay. Two times a year, if you're in this part of the world, you can experience a Lahaina noon, but nobody up here can. Now, something else is kind of interesting. This part of the world has very stable, warm temperatures, especially in Lahaina. Let's take a look at here it is, average temperatures. High temperature all year long in Lahaina is somewhere in the 80 degrees every single month of the year. Never a day you're going to need a coat in Lahaina. Even the low temperatures are relatively stable and moderately warm. But if you live in Virginia Beach, that's not the case. The months change and the temperatures vary substantially from 50 degrees for an average high in January to 87 degrees. That's almost 40 degrees warmer in the month of July. And the temperatures on the low end of the spectrum, down there near freezing in January, you can get some warm, low temperatures, if you will, in the summertime. But there's a lot of variation here. So we have seasons that change substantially. Okay. And before this lesson's over, hopefully you'll understand why. So let's go out in space and try to make sense of all this. There's our planet Earth uh, rotating, right? Giving everybody on planet Earth a little day and night. We can tell in this picture that the sun is off to the right. In fact, let's just go ahead, dispel any second guessing. There it is, way out there, about 93 million miles away. It's a lot closer, though, than other stars in the background. These stars are just tremendously far away. We can never travel to them. With our technology today, They're so far out of reach, we could never travel to them. We have a space probe out there going around the sun right now. Parker Solar Probe is doing just that. So we can reach that star. I'm not suggesting you want to reach it. It gets pretty hot the closer you get to it. And the way it shines on Earth, so it's shining this way, it doesn't actually shine on all parts of the Earth in the same way. Let's see here. Am I doing this right? There we go. So this line's called the terminator. It's just dividing the night side of Earth from the day side. And as the sunlight is shining on the Earth, it doesn't shine on all parts of the Earth in the same way. It's striking the Earth directly overhead right there. And if you look carefully, there's Virginia, there's the United States. Virginia Beach is right there. You're going to notice that Virginia Beach doesn't quite get to the point where the sun can be directly overhead. Now, that's not far. That's pretty close. But the sun here is where the energy and the sunlight is striking the Earth directly overhead. So if the yellow poles were here, they would not cast a shadow. This is where you can expect the warmest temperatures on Earth, wherever that may be. Now, let's let's continue with the animation here, and let's find Australia. Here comes Australia coming into view. Hopefully, we know that Australia is in the southern hemisphere. But if you notice, Australia is not going to get to a point anywhere close to a point where the sun is directly over their head. The sun would have to be this way to be shining over their head. Not going to happen. So no Lahaina noons on this particular day. This actually means, it doesn't mean they can't see the sun, right? They can still see the sun out there. But for the people in Australia, this time of year, they're looking low in their sky to see it. They're looking low. They're actually experiencing their wintertime when this picture was taken, or when the scene is right here. They're experiencing winter. Everybody in the southern hemisphere is experiencing winter. The northern hemisphere, I've got it set for June 30th. Up here, they're having summertime. Now, before we go too much deeper, I want you to notice something. The North Pole, a lot of students will look at this picture and they'll think the North Pole's right there. And that is just not the case. The North Pole is right there. Let's take a look. Here it is right there. So as the Earth rotates, North Pole right there. And you might notice that the North Pole is going to experience 24 hours of daylight. And it can do that for months at a time when the northern hemisphere is leaning towards the sun. But boy, does that confuse students too. So let's see. This first myth I want to dispel, if I haven't done so already, is that the Earth does not do this. It does not lean back and forth at different times of the year. And that is very confusing to some students, but it just doesn't do that, okay? What happens is Earth points at a star out in space. There's actually a star out there. Let's find it. We can probably do that. Let's locate that star. It's got to be out there over top. So out there over top of the Earth, um, Ursa Minor is our target. Absolutely. There's our star right there. That's the star Polaris. Let's click on it. There it is. That's the star that the Earth rotates underneath. So as we rotate, that star Polaris is over our North Pole every single day of the year. 24 hours a day. How about that? So doesn't matter what time of year, as we're about to see, that star is always overhead. Let's see, make that go away, make that go away. And how can we prove it to you? Well, we're going to, let's see, get us like that. We're going to change the date is what we're going to do. So let's click on the Earth and we're going to alter time. And instead of June 30th, which is pretty close to our summer solstice, which would be the first day of summer. Let's change to December. See how that changes things. Now, it may look to you like the other side of the earth is getting sunlight. Really, what's happening is the earth is going around the sun. So now we're on the other side of the sun. Okay. How can I show that to you? Well, let's see. Let's do it like this. We're going to go over top of the earth and we're going to notice, we're going to pull way back here and the sun should be off to the left. Okay. We can find it. We got to go way. Oh, there it is. Okay. So the sun's out there. So now earth is on this side of the sun. Whereas when we were in December, the earth was over here and the sunlight was coming in like this and the right side of this earth was illuminated. But now we're over here 6 months later. The sun's not going to move during this whole process. All during the year, the sun just sits in space, earth goes around it. And the whole time it goes around it, we're leaning in the same direction. There's our moon. Okay. So let's get back like this. The sun is this way now. This is, look, excuse me, the North Pole did not change the way it was leaning. The entire Earth is still leaning this way. But that means things have changed a little bit. So let's watch as the Earth rotates. And let's find Australia first. Okay. Where you at, Australia? There you are. Okay, here's Australia. And you'll remember last time, Australia was down here. They had to look low in their sky. They were not getting that intense sunlight. But look at them now. Look at them now. Let's go back a little bit. Look where Australia is now. They are in a position on Earth where the sun is blasting straight down on them. They are absolutely experiencing some locations in Australia a Lahaina noon. They are having some very hot summer days now. This part of the earth in the southern hemisphere is experiencing their summertime. But where's Virginia Beach? Let's see. Where's Virginia Beach? There's Africa, so we must be coming up here. Let's see if we don't come into view. South America. Where are we? There we are right there. So let's notice Virginia Beach. We go back a little bit in time and let's compare where Virginia Beach is now to where it was before. Virginia Beach is way up there. Sun's not coming in directly over Virginia Beach's head. We have to look low in the sky to see the sun. The whole situation is reversed. Now the people in the southern hemisphere are receiving the direct sunlight. And down here, the water and the air and the land can be heated efficiently by the sun's energy. But the same sunlight striking them directly is coming into us at a very shallow angle. The energy is spread out. Same amount of energy, but spread out over a large area. And that means we experience cooler temperatures and a colder climate. And that's our winter time. We actually have the season winter when we lean away from the sun. And that's how the seasons change. It's really just a product of the Earth's leaning over in space and going around the sun. Sometimes students mistakenly believe that the seasons are caused by how close the Earth and the sun get. That's not it at all. Don't be the student that mistakenly puts that answer on a test or quiz. It's the angle of incoming sunlight and the way it strikes the earth at different locations that causes the seasons to change. Now, if we go to some software like Stellarium, give you some activities you can do to kind of convince yourself of some certain misconceptions, make sure they're not blowing your mind. Let's turn around and face north here. And we're in Virginia Beach now. And you'll remember I said, well, the earth leans in the same direction all year. Here's how you can prove it to yourself. So In Virginia Beach, we are about 36.5 degrees north of the equator, meaning the star Polaris is about 36.5 degrees above our northern horizon. It's right out there. And if you don't believe me, you keep focusing right there because it's there day and night. I'm going to rotate the Earth, and there it is, right there. Polaris, about 400, I think it should be a little over 400 light years away, 432 light years away. It's out there in space. It's not going anywhere. It's not over top of Virginia Beach where we'd have to look straight up to see it. It's out there over top of the North Pole, and we have to look low in our sky to see it. Now, here's the Big Dipper. That star is called Kochab. There it is. Watch how Kochab and the Big Dipper, and in fact, all of the stars look like they go around the North Star, while the North Star sits right there. Doesn't appear to move. And the tricky part is none of the stars are moving. It's just the Earth rotating. That's what we're demonstrating for you right here. Okay, and I'm going to keep it dark. Let's do that so that you can see what's going on. Even the sun looks like it goes around Polaris over time. Now, if the Earth changed the way it leans throughout the course of the year, then in, say, April, that wouldn't be our North Star. But let's just do it slowly. Let's go to September and see if the North Star is still there. It sure is. It's right there. Oh, that's a Starlink satellite. There we go. So there's Polaris in September, October, November, December. All throughout the year, we're leaning, the whole planet, still leaning in the same direction, and that star is in the same place. How about that? So that should convince you, hopefully, that the Earth doesn't do this. We're not changing the way we lean throughout the year. We lean the same way, and the North Pole is either going to be leaning towards the sun when we're on one side of the sun, or leaning away from the sun when we're on the other side of the sun. And that going around the sun combined with leaning over in space is what changes where the Lahaina noon is, where the sun is coming straight down on the surface of the Earth and concentrating its energy, consequently heating it up and making it summertime wherever that is. I hope you enjoyed this lesson, and hopefully, if you have to, you can rewind the video or go over it a couple times. It's not something that may sink in right away that first time. It takes a little practice, as a lot of things about astronomy do. Until next time, this is Chuck, wishing you many star-filled nights.